Good morning, sir. My name is Kushagra Agarwal. My roll number is 17UCC033, and today our topic of presentation is JSON-based secure web tokens, abbreviated as JWT. This is an authentication mechanism that can be used for API to API authorization and also as a session management system to keep a track of the logged in users. And it provides us with a method so that we can authenticate the genuinity of each user who is requesting the resources that are strictly prohibited to legitimate users. Traditionally, cookie-based sessions were used to keep the user logged in after authentication. JWT has various advantages over the system, with the most prominent one being the reduction of network requests on the database server, thereby reducing the total traffic, and at the same time avoiding latency. This mechanism does not maintain a list of sessions of all logged in users. Instead, it verifies the identity of the client on each and every request. JSON Web Token combines various technology stacks and protocols such as HTTP protocol, the SSL protocol, that is a security layer over the existing HTTP protocol, encryption, public-private key concepts, and bearer token, to name a few. These concepts will be discussed in greater detail further. Thank you.
My name is Karuvia, 17 UCS 167, and I'll be explaining the topic, how is a JWT token generated? As we know, JWT token consists of three parts: encoded header, encoded payload, and signature. The first part of the token is termed as encoded header. The algorithm which we have used here is hash-based message authentication code HMAC by using the SHA-256 hash function. Using this algorithm, we create a buffer from a JSON encoded object, and then we encode it using base64 scheme, and we get a partial result. Number 2 is an encoded payload. Encoded payload consists of two reserved keys, namely ISS and EXP, which helps the user to identify the issuer and the expiration time. Payload can be customized with any kind of data. We can add our own data to the token by using an object, as we can see in this equation. We convert this object, JSON encoded, to a buffer, and we encode the result using base64 scheme. The two results which we've got, encoded header and encoded payload, is used to form a signature. Signature is an important concept because it makes sure that the content cannot be changed even if intercepted by someone. So this signature is generated using the header and payload content. Using CryptoNode module, a secret key, header and payload content, we create a base64 encoded form. As we can see in this equation, we have a secret key, we have the content of encoded header as well as the encoded payload, and then it is all encoded using a base64 scheme, and hence we get our signature. So finally concatenating these three parts, namely header, payload and signature, and separating them with a dot, we get our JWT token. Thank you.
Hello, my name is Kanishka Jain. My roll number is 17 UCS 077. So we have used HMAC SHA-256 algorithm in our project. Hash-based message authentication code is a signing algorithm which involves cryptographic hash function and a secret cryptographic key. It is used to ensure the integrity and authenticity of the message. It does not encrypt the message. Instead, the message is sent alongside the HMAC hash. The receiver then again computes the hash value and checks if the calculated value matches with the received value, and if it matches, then the receiver will be assured that the message is authentic. So in this algorithm, we first take the XOR of key dash and iPad and concatenate it with our message and compute the hash of it, and then we concatenate it with the XOR of key dash and opad and again perform the hash of it. So if the size of our key is less than or equal to block size, then we take the key as it is. But if it is larger than the block size, then we perform the hash of it. So here H is the cryptographic hash function, M is the message, K is the secret key, OPAD is the block sized outer padding, and IPAD is the block sized inner padding. So this is how this algorithm works. We calculate the IKeyPad value by taking XOR of key and IPad, and we calculate the OKeyPad value by taking XOR of key and OPAD. Then in the next step, we concatenate our message with the IKeyPad and perform the hash function and obtain hash sum one in the SHA first pass. Then we concatenate hash sum with the OKeyPad and perform the hash function and obtain hash sum 2 in the SHA second pass. So as you can see, we have used hashed twice in this algorithm.
My name is Ashutosh Sundriyal, 17UCC017, and I'll be speaking on session management. A web session is a sequence of network HTTP request and response transactions associated to the same user. Web applications can create sessions to keep track of anonymous users after the very first user request. Additionally, web applications will make use of sessions once the user has authenticated. This ensures the ability to identify the user on any subsequent request, as well as being able to apply security access controls, authorized access to user private data, and to increase the usability of the application. Here, accessing of data is very fast as it stores session data in memory object of the current application domain. We know that HTTP is a stateless protocol. So when there is a series of continuous request and response from the same client to a server, the server cannot identify from which client it is getting requests from. So when there is a need to maintain the conversational state, session tracking is needed. The session ID or token binds the user authentication credentials in the form of a user session to the user HTTP traffic and the appropriate access controls enforced by the web application. The complexity of these three components, that are authentication, session management, and access control in modern web applications, plus the fact that its implementation and binding resides on the web developer's hands, as web development frameworks do not provide strict relationship between these modules, make the implementation of a secure session management module very challenging. These days, web applications are very advanced and usually handle complex operations which take more than one pair of request response to complete. This requires something to track the present state of the operations. This requires identifying a user across multiple requests. So there must be something that adds an enhancement to HTTP.
My name is Sarthak Kanodia, and today we are going to talk about authentication and authorization model. Cloud computing is significantly reshaping the computing industry. It has emerged as the key technology that unleashes the potential of big data, IoT, mobile, and web applications. But it also comes with its challenges such as governance, security, and privacy. User access protected resource via secured JWT tokens. When a resource access policy is updated and user access token is still valid, it could be a challenge. It can introduce a time-based vulnerability on the protected resources. And with multiple users accessing the resource, the vulnerability index can increase exponentially. An authentication and authorization model will limit such vulnerability and enhance the secure resource access. So, now we are going to look about the authentication and authorization model. User accesses are monitored and mapped to be in tandem with the current resource access policy. Every user request call to the resource goes through a policy match gate, and event or process is monitored by a policy activity monitor, which ensures that user access tokens making the request call have the appropriate RAP, that is the resource access policy, even through the token is still valid. Now we'll see that how it is more secure. This would eventually reduce the overhead which might occur from frequent calls and transmissions of the tokens via HTTP header. This is a sample of the model for the authentication and authorization. Here, authorized user access the protected resource in two ways. The first way is with the valid access token and no update on RAP. And second method is with the valid access token but with an update on RAP. In the first method, the request goes through a policy match gate, which is PMG, and it goes directly to the secured resource. And in the second method, the request goes through policy match gate and then it is checked on activity monitor. So to check the updates in the RAP, and then it goes to the secured resource. Now, as for the future scope, we are looking to compare our JWT with secured assertion markup language. JWT is based on JSON used in authentication and authorization protocols, as we have seen, and SAML is based on XML used in protocols like WS Trust, WS Federation. JWT is ID token based to pass user information as header, payload, signature, structure, and SAML is open standard for exchanging data between security domains. And JWT is based upon the REST APIs, and the second one is based upon largely on SOAP based. So this was the future scope of our project.
Hello, this is Utkarsh Kulshrestha, 17 UCC 063. I'm hoping that my friends have already explained you what JWT are and all of the keywords, the three keywords in general, which we have taken. So I'm gonna walk you down through this code, which we have written to show the implementation of JWT. This is basically made in Python. There is authentication, there are token generation and stuff like that. And we are basically, what we are doing is we are authenticating the APIs which we have made. So we have followed MVT structure for making this application. These are going to be a couple of I guess views through which we will create some functionality. So I'll just go ahead and start this project, like run server. Okay, so here we are running. I mean, the server is live. This is the API route. What I'm gonna show you is like this. Where it is? Yeah, this is the command that we are going to use to generate the token. A user has already been created and it's saved in a database. So I'll just send the file. So it generated a authorization token for a user. Like this is the user. His username is UTK and password is most. So what we're gonna do is we're gonna take a protected route, and first I'll show you without authorization what if we doesn't pass this token. So if we didn't pass the token, it's just going to say authentication credentials are not provided. But instead of it, if we'll pass a JWT, JSON Web Token, what it will do is with the header, it will send a encrypted base 64 encrypted string that will act as a JWT. So when I'll send it, you can see that this is JWT, alright. So all of the protected routes are now working. So that's it. And we can also post, I mean, if you want to add something to the database or add something via this routes, that thing is also working. Like in the body, just change cloud computing. So when we'll send it over to the server, see, we received a callback URL, and the callback does have URL, username, description, and sample utterances. So we can also check by getting the product, like entity number 10 it is. So we'll just send the get request, and I guess at the, yeah, it popped up right at the bottom. So this is the working of the code, and I believe you can very well go through the documentation and you can see the working of the code yourself. This is basically generation of what token is going to be. Like Kushagra and some other, I think Kanishka and Taru has already explained in their videos how all these things are generated. So I basically took up the algorithm and developed these myself, like these payload things, and then verifying these JWT, verifying that string. And here I am just using it for authentication. So we'll be sending you over the code as well. Yeah, that's it from my side. Have a good day.